Welcome back to another episode of the CSK8 podcast. My name is Jared O'Leary. As you may have noticed by now, every single week it's going to alternate between an interview and unpacking scholarship. And this week I'm going to start a little mini-series on modding. Today's episode is going to be on some practical implications of modding or remixing a video game. And then 2 weeks from now, we're going to have an episode that dives deeper into what mod culture is. And 2 weeks after that, we're going to take a look at a study that looks at the potential motivations and implications of people who engage in modding. Now, if you don't know what modding is, I will talk about it in this episode. And if you want to learn more about it outside of the 3 episodes that I'm going to record on this, you can actually take a look at chapter 2 in my dissertation, which I will link to in the show notes. In that chapter, it has a summary of what mod culture is and kind of points to some more scholarship that I won't be discussing today. So today's article is titled Learning Through Game Modding, and it is by Maggie El-Nasr and Brian Smith. And as always, apologies if I ever mispronounce any names. And as a friendly reminder, you can find links to Google Scholar profiles in the show notes, so you can find out more scholarship by these authors, and you can also take a look at this actual publication if you're interested in reading it. Okay, so here's the abstract. Quote, there has been a recent increase in the number of game environments or engines that allow users to customize their gaming experiences by building and expanding game behavior. This article describes the use of modifying, or modding, existing games as a means to learn computer science, mathematics, physics, and aesthetic principles. We describe 2 exploratory case studies of game modding in classroom settings to illustrate skills learned by students as a result of modding existing games. We also discuss the benefits of learning computer science skills, example, 3D graphics and mathematics, event-based programming, software engineering, etc., through large design projects and how game design motivates students to acquire and apply these skills. We describe our use of multiple game modding environments in our classes. In addition, we describe how different engines can be used to focus students on the acquisition of particular skills and concepts. End quote. If I were to summarize this study in one sentence, I would say this article describes 2 case studies on modifying video games to learn software development and design, as well as programming, artistic, and video game concepts. The authors begin by talking about some of the benefits of modding. In particular, they talk about instead of creating a program or a video game from scratch, modding can actually save a lot of time, cost, and expertise. In particular, they talk about how a video game is typically made by a large number of individuals working together on a project. However, when you're modding, you can actually build off of their efforts, essentially standing on the shoulders of giants, to just kind of customize a game to make it work in the way that you want, rather than having to go through and be like, okay, I need to record all the sounds, and I need to develop all the characters, and I need to program all the characters so that they have fluid movement and responsive player controls, etc. So instead of having to do that kind of tedious stuff, you can actually augment those things that other people have already created. In addition, there's a quote on page 2 that says, quote, since modding begins with popular, proven game concepts, the resulting variations are more likely to resemble games that players, modders, are accustomed to than if they had to build entire game infrastructures on their own, end quote. I think that's a really important quote to take into consideration. To kind of situate this into a K-12 classroom setting, think of modding as remixing a project in Scratch. So somebody else has created something in Scratch and you go into it and you're going to vary it in some way. So you're going to change the code, you might change some of the sprites or some of the sounds and things like that. And if you're not using Scratch, think of it as just taking any kind of a video game or program and you are making it do something that it wasn't originally intended to do. So an example that I brought up multiple times is I modded the game Minecraft to put our dogs in it and to make quests for my wife and some items that I know that she would like and whatnot. And rather than having to recreate the entire game Minecraft from scratch on my own, all I had to do was go into the actual game files and kind of add in my own code that augmented it in a way that I found personally meaningful. So on page 2, the authors talk about how by modifying existing video games, students or kids can learn by design. So here's a quote on page 2. Quote, during the design process, skills such as analysis, synthesis, evaluation, and revision must be used, providing opportunities for learning content and metacognitive skills such as planning and monitoring. Students can receive ongoing feedback from peers and experts when constructing working artifacts. Feedback also comes during the process of construction as students work to understand how and why their designs fail, can be optimized, and so on. Finally, real design problems have multiple solutions, allowing students to see and evaluate alternatives. End quote. Now, I think there are several really excellent points in that particular quote right there. Now, one of the things that I really love about working with computers and programming is if you have a platform that allows you to modify something and you can instantly see the results, it gives you instantaneous feedback. So for example, if you change a variable in Scratch while the program is running, you'll immediately see maybe the character get faster or slower or something like that. This makes it really easy to modify a program and kind of learn from experimentation and potential failures and ways to optimize some things. However, if you're working in some kind of environment that requires you to compile a program, that can take a long time. So even just modifying like one variable, like changing the speed from 5 to 10, and then hitting that compile button, it might take several minutes, and then you'll test it out and go, oh, well, that failed. And then you go back and modify the variable again and change it from like 5 to 7. And then you have to hit compile, and it's just kind of a waste of time. So if you have a platform that allows you to see instantaneous results in whatever it is that you're modifying, I highly recommend using that when remixing or modifying a program. And a little bit further in the introduction, the authors mentioned that game design in particular, it can be very motivating for students. For example, on page 3, here's a quote. Students enrolled in experimental computer science classes that used game design averaged higher grades than control classrooms. Additionally, 88% of the game students continued in the major compared to 47% for the control groups. Combining constructionist pedagogy with game design seems to help some students dig deeper into computer science fundamentals, end quote. So this was with undergraduate students enrolled in a computer science program. They found significant difference between people who modified video games, or rather engaged in game design, and people who did not. Now, I'm a little bit skeptical of those results. I'm kind of curious like how the design of the study was, but I just haven't read it. Seeing those differences is pretty drastic. It makes me go, well, maybe there's another reason for that. But that's no knock on the authors that they're citing. I'm sure it's a good study. And again, the authors bring up that while these studies are great and it shows that students might be really engaged in video game design, however, there's a significant amount of time, cost, and expertise that can be significant barriers when trying to engage in video game design. So what they recommend is an alternative, which is rather than creating a video game from scratch, not in Scratch, but from scratch, from nothing, actually going into an existing one or a semi-completed one and modifying that to create something new. Now, one of the interesting things that they point out is that modding practices are engaged with by a lot of people in the video game world, usually for leisure. However, what's interesting about mod culture is that a lot of modders end up getting hired by video game companies. So a modder might remix a game or change it and add in some new content, and it could get the attention of that developer. And sometimes the developers will actually reach out to the modders and offer them contracts to come work for them. There's actually been several different studies on how mod culture and modding practices are often viewed as kind of like a pipeline into the video game industry. However, again, this is also something that can just be done in leisure for fun. So the first case study is actually on high school students who are in Pennsylvania in a school, and there are 20 students who are enrolled in an IT class, and they had 3 consecutive days with 3 hours each day to work on the game modding. And the mods that they actually worked on was for the video game Warcraft 3. Now, Warcraft 3 is a real-time strategy game where it's you versus enemies, and you're going to basically build up a base and recruit a bunch of soldiers, and then you're going to use those soldiers to attack an enemy or enemies. I honestly forget if this was a multiplayer game or not. I played this at least a decade or two ago. However, what's really interesting is the students who modded this game actually turned it into games like a football game or a Tetris-style game or whatever. So through modding practices, they actually completely changed not only how the game looked, but the actual gameplay itself and what the overall purpose of a particular game was. Now, an interesting point that is made on page 7 is that students did not simply go through a lesson that showed them how to do everything and then they just kind of created their own variations upon that. They actually talk about how these students learned how to do the mods by, yes, consulting instructors, but also consulting web resources such as like message boards and tutorials that existed outside of the classroom itself. Now, I think this is a really important thing to note, that if you are going to engage in any kind of modding practices, I highly recommend having an abundance of resources that kind of can guide students in different directions. And these can be resources that you create or curate. So for example, when I engaged in modding practices in the K-8 classes that I worked with, I had a bunch of tutorials that kind of showed you how to do things for some platforms, but then in other platforms, I simply had in comments. So like in Scratch, I might have had a completed project, but I included comments in there that showed what each chunk or function of code would do. And then I'd always end those comments with questions that would encourage further modifications. So for example, if a comment was discussing how player controls work, at the end I would say, how would you make it so this player moved faster or slower? Or how would you make it so that this player moved like they were on the moon or swimming underwater, etc. So getting kids to think through different ways that can modify things in order to augment the game in a new way that wasn't originally intended. Now, the second case study that is in this particular publication is on 35 undergraduate students from Pennsylvania State University who are in the Department of Computer Science and Engineering and School of Information Sciences and Technology. That is the longest school title I've ever heard. I think they should win an award. Now, in this particular class, students worked in groups of 5 to develop a game of their choice using any of the engines that they learned in the first half of a semester. Now, one of the interesting things that they point out in this particular case study is they talk about how students didn't have a great knowledge of basic geometry and vectors. So when they were trying to do something in the game and were kind of stuck because of their lack of understanding on it, the instructors actually gave some lectures to kind of help understand those concepts. And then afterwards, students reported that they understood the content better and could apply it in their games. Now, the reason why I point this out is because it's interesting that using a constructionist process where you're supposed to kind of like learn by creating something, that they're also combining it with direct instruction. Now, I actually mentioned in a podcast that's going to release in a couple of weeks in an interview with John Stapleton that I don't think direct instruction should be avoided at all costs in favor of more progressive approaches that are in alignment with constructivism or constructionism. However, I do think that it needs to be limited so it's not like, okay, we're going to lecture for 90% of the class and then the last 10% you're actually going to create something. So there needs to be some kind of a balance between active creation and then kind of like the passive receiving of information. Now, that being said, I also want to point out that if you are engaging in constructionist practices and you're saying, hey, here's a resource that can help you out, just because you're not the one who's giving the lecture, they're still technically getting direct instruction from the resource that you're providing to them. So that's kind of to provide a little counter argument to myself. And on that note, one of the really interesting things that they mention on page 14 is, quote, we deduced that students didn't understand the implication of these concepts until they applied them in a complex and relatively large-scale project, end quote. In other words, this is going back to what I mentioned before in a previous podcast about situated learning. You need to learn some kind of a concept or practice or understanding within a moment where you actually apply that understanding. Otherwise, it's decontextualized with what you're going to need it for. So one of the famous examples that a lot of people bring up is math classes. And I'm sure many people listening can reminisce and think about how they might have had a similar experience where it's like, okay, I'm learning how to solve all these equations, but I don't know when I'm actually ever going to use these. And from what I have heard from math educators is that they kind of get a bad rap and things have changed in math education, so it's more situated within something useful. However, unfortunately, it still has the reputation of being decontextualized from useful applications. So that being said, this kind of also reinforces the idea that you don't need to sit there and lecture on something out of context, but if instead you give an environment where kids are trying to apply their understandings in a situation where it's needed, then that can actually lead to better understanding of that concept or practice. Now, an interesting finding out of this second case study is they actually compared how interested students were in an assignment where they kind of had to design a video game environment and move a character around versus a second type of assignment where students had to modify an existing video game, the Unreal Tournament video game. And what they found is 46.2% of people who engaged in the first example where they are developing an environment and moving a character enjoyed that process or were interested in it. However, 88.4% of people were engaged or interested in the Unreal Tournament example where they were modifying an existing video game. So this demonstrates that this could be a highly motivating experience for some kids. So the discussion for this particular study leads to 4 different categories. The categories are software development and design, programming concepts, artistic concepts, and game concepts. So those are the 4 categories of skills and concepts that students engage in. So let me unpack them. So this is on page 17. When engaging in game design or modification, students will engage in software development and design that is comprised of teamwork, building critiques and reflections on others' works, project scheduling, project management, iterations and refinement, and prototyping. So all those things that can be really helpful for any kind of content area, just not just computer science in general. However, for the computer programming concepts that are learned, they mention that students learn threading and event-based programming, object-oriented programming, component-based development, and software patterns. And then under the artistic concepts, they mention that when engaging in game modding, that students learn lighting effects, architecture design, and character design. And then under the game concepts, they mention that students learn game design, game mechanics, and balancing game aesthetics and gameplay. So in other words, to kind of summarize the main gist of this, when you're engaging in video game modification practices, 1, students might be very motivated by this if they are interested in video games. 2, they can learn a lot of things that are relevant not only to computer science, but to other areas as well. And as you'll hear in follow-up episodes where I kind of unpack mod culture some more, it's not just in visual art concepts, but there's also like sound pack mods where people modify sounds, and there's all sorts of other domains that this can potentially connect with. This also allows students to have a very quick onboarding into creating something that can be interesting to them. So rather than having to go from a blank page in an IDE, create something over many months to just make it so that a character can like walk forward and backwards, you can start with an already existing game that is already functioning, or maybe even partially functioning, and then adding in new things that make it do something different. And this can be done as early as like kindergarten. If you were to, let's say, use Scratch Junior, you could, if using like an iPad or some kind of device where you can share your projects, you could share an existing project with kids and just ask them to change it. Or even if you don't have that ability, you can simply say, okay, kids, for the first half of the class, you're going to work on this project, and you're then going to pass it to a neighbor on the second half of the class, and they're going to add to it or modify it in some way. And then at the very end, we're going to talk about what you did and what you were able to do with another person's project. So that's kind of an example of how you could use this in kindergarten and above. Now, in the curriculum that I created for the kids that I work with, I had a lot of examples of completed or semi-completed projects. And again, one of the important things that I want to emphasize is that I included a bunch of comments and questions that really kind of guided kids to understand what they could potentially do by experimenting with changing variables or adding in new sets of code inside of the various algorithms they were modifying. So if you haven't tried game modding yet, or just modding or remixing in general, I highly recommend experimenting with it in some of your projects. So whether it's giving them a completed project and having them read the comments and questions and figure out what they can do, or maybe even giving them a completed project and asking them to create the comments that explain how this project works, or maybe giving them a semi-completed project that's like, well, the character moves, but the second player doesn't move. So how can you modify this game to make it so the second player moves, and then turn it into some kind of a game of your choice? So those are some different options for you. Now, I do have some lingering questions or thoughts for this particular study. So one of my lingering questions when going through this article is, I wonder, why do some coding platforms encourage modding or remix practices, kind of like Scratch, which is community-based and it's super easy to just click a button and then you've remixed somebody else's project, while other platforms do not afford such possibilities? I'm wondering if there's a specific reason why people are choosing to not encourage or enable such practices. Because there is a lot of scholarship out there on how modding can be very motivating, or it can be a really great opportunity to learn computer science and other disciplinary concepts and practices, as demonstrated in this particular study. So a second lingering question that I have is, if modding practices are so great, why not do them all the time? In other words, at what point should we encourage developing something from a blank slate instead of modding existing code? While I personally know, as somebody who's engaged in modding practices and somebody who's facilitated modding practices with elementary and middle school kids, I know that this can be a very beneficial thing, but I also know that it can be really beneficial to start from a blank page and learn through those processes of thinking through, okay, if I want to make a character do X, Y, and Z, I need to create functions that do X, Y, and Z. So how do I start creating those functions, and how are they going to all kind of work interdependently and interconnectedly? However, I know that can also be very frustrating for kids. So if there's any recommendation that I can give is, rather than picking one end of the spectrum or the other in terms of to mod or not to mod, I would say give both options and everything in between. So you can be like, hey kids, if you're interested in modding, you can do that, as long as you're not just sitting there and changing colors of things, but actually changing the code. Cool, awesome. But if you'd rather create something from a blank page and go from there, awesome, you can do that too. Now, to kind of argue with that approach, I have heard from several software engineers or computer programmers who say you almost never start anything from a blank page. You're almost always starting from what other people have already done. So modding practices are very common, even outside of the game world. So I hope that introduction to modding practices through this particular study was useful to you. The next two Unpacking Scholarship episodes will kind of unpack mod culture a little bit more. However, next week is going to be an interview. Just as a friendly reminder, if you want to actually read the entire paper, you can find that in the show notes, and that's available at jaredoleary.com, and just click on the CSK8 podcast. You should also be able to find it in your podcast app by clicking the link below, and it'll take you directly to the show notes. If you haven't done so already, I would love it if you could share this with somebody else and to the broader community. That would mean a lot to me, because I'm just trying to create a bunch of free resources that help out other educators. And with that, I want to thank you so much for listening to this episode, and I hope you look forward to next week's interview.